Welcome back to our series on linear graphs. In this video, we're going to look at the method of using x and y intercepts to draw a graph. So here we have a line graph. We can see that it's pointing downwards, but if we look at various points along here, it can be a bit difficult to work out what the actual coordinates are. So for example, if we look in the middle in here, we can't tell easily what those exact coordinates are. However, there are 2 points where it's very obvious, where we are crossing the y and the x axes. And we notice that where we're crossing the x-axis, the coordinates are 6 for x, 0 for y. And where we are crossing the y-axis, the coordinates are 0 for x and 3 for y. So what we can see from this is that the x-intercept is when y equals 0. The y-intercept is when x equals 0. So now we're going to use that. So if we are given an equation here and we want to graph it using this method, first of all, we want to find where it crosses the x. So we let y equals 0. We substitute that into our equation. So where we had y, now we have a 0. So 0 equals 2x minus 4. We have to rearrange that now. So we are going to add 4 to each side, so that now we have 4 equals 2x. We want to get rid of this 2 in here, so we divide everything by 2, and we get x equals 4 divided by 2, which is 2. So we are going to mark that point there. To find the y-intercept, we let x equal 0. So we have y equals 2 times 0, which is 0, minus 4. So it's going to just be minus 4. And then we can now join those points. Be a lot neater if I used a ruler, obviously. We notice that the y-intercept, minus 4, is the same as the minus 4 we have in our equation. And if we look at the basic form for a line graph, y equals mx plus c. C is our y-intercept. So if I have y equals 2x plus 3, plus 3 would be our y-intercept, because when we say x equals 0, we'll have 2 times 0 plus 3. This is 0, so we'll have y equals 3. So let's practice this a little bit. We want to find our x-intercept. So we say let y equal 0. 0 equals 3x minus 3. We add 3 to both sides. So we'll have 3 equals 3x. We divide by 3 and we'll just get x equals 1. And then we can look at our equation and see here what the y-intercept will be. Negative 3 here, and then we can join our points. Y equals negative x plus 4. This graph is going to be pointing downwards like this because it has a negative gradient here. We start off, let y equal 0. 0 equals negative x plus 4. We want to get that 4 onto the other side. So we do minus 4 from both sides. Negative 4 equals negative x. So x will be 4. And then we look here for our y-intercept. It is also 4. And we draw our line in. One more before we look at some variations. Let y equal 0. 0 equals a half x minus 3. We add 3 to both sides. 3 equals 1/2 x. So if 3 is a half of x must be 6. Right over here. And y is minus 3 here. And then we can join them up. Now, this will work even if you're given the equation in a non-standard form. It just means that we're going to actually have to work out the y-intercept instead of just looking at the equation. But we will do the same thing. We'll start off, let's find x. So we'll have 2x plus 0 equals 4. X will be 2. Now we're going to let x equal 0 to find y. So we'll have 2 times 0 plus y equals 4. Y will be 4 here. We can join them up. Something to note, if we have a line going through the origin, which is 0, 0, we actually only have one intercept. The x and the y intercepts are the same. So for example, y equals x just goes through here. If we have this, you want to use a different method for graphing, or you can just start with this and then change it according to the gradient. So y equals 2x, it will go up 2 squares for every one it goes across. Y equals negative 3x, it's going to be quite steep and it's going to be pointing downwards like this. So it would go down 3 squares for every one. So there, very wobbly line, sorry. There. What we're going to do next is we're going to look at how we find the gradient from a graph. Thank you.